Hello again, welcome to another lesson in geometry. Today we're covering section 10-6, circles and arcs. So we have some vocabulary first. Is a circle a two-dimensional figure? And this should be yes, has length and width but no height, so we couldn't find the volume of a circle. Is a circle a polygon? And this should be no, okay. Is every point on a circle the same distance from the center? And this should be yes. Circle the figure that is a circle. All right, so that's the second one. This guy's an oval. Don't know what that is. And that one's not a geometric shape that we give a name to either. Okay. All right, so vocabulary builder. We have an arc. An arc is a part of a circle. Okay, so we have some related words. We have minor arc, major arc, and semicircle. So a semicircle is an arc that is exactly half of the circle. A minor arc is an arc that is less than half, and a major arc is an arc that is more than half of the circle. So semicircle AB is an arc of the circle. Okay, so AB is this red part from here to here. Okay, and that's a semicircle. Underline the correct word to complete each sentence. A minor arc is smaller than a semicircle. Okay. A major arc is larger than a semicircle. You can use 2/3 points for a major arc. You should use 3 points for a major arc to show that it's going around, okay, which way it goes. And you could use 2 points for a minor arc because that's going to be the short way, okay. Circle the name of the red arc here. So the red arc, we will use just the 2 points we need. So it would be between K and L or L and K. So your choice, only one that matches is this, KL. All right, so for a major arc is a blue one, and a major arc needs 3 points, so we can automatically mark off JK and KL. So we do need to go from K to L, but we need to go around the big side, so that's why we need the 3rd point. And J is between K and L, so this is the one we're going to use. Okay, on our second page, we have problem 1, naming arcs. We'll do a little practice with naming our arc. What are the minor arcs of circle A? Draw a line from each central angle in column A to its corresponding minor arc in column B. Okay, so the central angle, remember, goes from the outside of the circle to the center and then back to the outside. So PAQ's central angle is here. Okay, and the arc that goes with that is going to be PQ or QP, but they have PQ here. So we're going to combine it this way. All right, QAR, the central angle is here, QAR. So the minor arc that goes with QAR is going to be QR or RQ, but QR is the one that they showed for the name of. Okay, so remember we can name an arc either way using whichever points we want to begin with. So QR or RQ are the same arc. All right, so RAS is the central angle, and that means we're going to be talking about this arc right here. So SR will be ours, but in this case it's named RS. Okay. SAP is talking about this central angle, so we're going to name this arc, which would be SP. And then SAQ is talking about this central angle, so we're going to name SQ as the minor arc that corresponds with it. So the minor arcs of circle A are, well, let's just list them. RS, SP, PQ, QR, and SQ. Okay, so there's a minor arc that's associated with every central angle there. Key concept, arc measures, and this was postulate 10.2, so we don't have to prove it. So the measure of a minor arc is equal to the measure of its corresponding central angle. So the measure of a major arc is the measure of the related minor arc subtracted from 360. So the measure of a semicircle, that arc is going to be 180 because its central angle is exactly 180. Okay. So use circle S at the right for exercises 17 and 18. The measure of arc RT. So RT is this arc, and it's going to have the same measure as the central angle, and the central angle is RST, so both of them will be 50 degrees. Okay. Then we want to know the measure of the major arc TQR. So TQR is this major arc right here. Okay. It's going to be 360 minus the minor arc, which was 50. So that will give us 310 degrees. Postulate 10-2, arc addition postulate. So the measure of an arc formed by two adjacent arcs is just the sum of the measure of the two arcs. So just like anything, or segment addition or angle addition, if you want to find the measure of an arc that's comprised of two smaller ones, you can just add the two smaller ones together. So use the circle at the right for exercises 19 and 20. If measure of arc AB is 40, so this much is 40, and the measure of BC is 100, so that part is 100, then the measure of ABC is going to be 100 plus 40 for 140 degrees. Okay. The measure of the measure of arc AB is equal to X. So in this case, AB is X. And the measure of BC is Y. Then the measure of ABC would be X plus Y. All right, so finding the measure of arcs. What is the measures of arc PR, RS, PRQ, and PQR in circle C? So we have two minor arcs and two major arcs. All right, so the measure of angle, the central angle PCR, PCR is 77 degrees. So the measure of arc PR would also be 77. And on page 3, we have number 22, which is we're trying to find the measure of arc RCS. So we want to know this one, the central angle here. All right, so the central angle RCS is going to be equal to the measure of PCS, which is 180, because that's a semicircle, central angle, minus PCR, the one that we know the measure of. So we could do 180 minus the 70, let's see, was that 72 or 77? 77, okay, and that will give us 103. Okay, so the measure of our central angle RCS is 103. All right, so the measure of RCS is equal to 103 degrees. So the measure of the arc RS is going to be 103. Now we want to find the measure of arc PRQ. So PRQ, let's see, there's P, there's R, and then we keep on going around to Q. So PRQ is a major arc. That's why it has 3 letters to name it. And that's going to be equal to the measure of arc PR plus the measure of arc RS plus the measure of arc SQ. All right, so that's going to be 77 plus 103 plus 28, which would be 208. Okay. Now you could have also found it by just doing PCS, which was our semicircle, so that would be semi-arc, so that would be 180 plus the QS. All right, so measure of arc PQR. All right, so PQR goes around the other way. We want this arc, PQR. So that's going to be 360 minus the part we don't want. So the part we don't want was 77. So 360 minus 77 will give us 283 for the measure of that arc. All right, theorem 10-9, circumference of a circle. So we've seen this formula for a long time. So the circumference of a circle pi is pi times the diameter. You could also do 2 pi r because remember 2 radius is the diameter. So explain why you can use either pi d or 2 pi r to find the circumference of a circle. And that's really fast. It's just the diameter is equal to 2 radiuses. So it takes the place in either one we want in the formula. Okay. All right, problem number 3, finding a distance. So a car has a circular turning radius of 16.1 feet. Okay. So that means if you turn the wheel as much as you can to the right, it'll make 16.1 feet as the radius to get around the circle until it comes back. So the outside tire will draw a circle that has a radius of 16.1. Okay, the distance between the 2 front tires is 4.7 feet. How much farther does the tire on the outside of the turn travel compared to the tire on the inside? All right, so we need to find 2 circumferences here. One for the outside tire in blue, and one for the inside tire in red. That's what the question's asking us, and then we're going to subtract them and see how much farther. So the 2 circles have the same center. To find the radius of the inner circle, are you going to add or you're going to subtract? And this should be subtract. We know the radius of the bigger one, so we subtract off the distance between the 2 tires on the car, the 4.7. So the radius of the outer circle is 16.1. And the radius of the inner circle is 16.1 minus 4.7, which is 11.4. So the circumference of the outer circle is going to be 2 pi times the radius of the outer circle. The radius of the outer circle, remember, was 16.1. And 2 times 16.1 will make 32.2 pi for our exact answer for the distance the outside tires will travel. So now we want to know the distance the inside tires will travel, which will be 11.4 for the radius times 2 pi, which will make 22.8 pi for the distance the inside tires will travel. So to find the distances, find the difference between the 2 distances, we're going to do this. 32.2 minus 28.8, both of them have pi. And then 32.2 minus 22.8 will make 9.4 pi. That's our exact answer, but we're rounding this one, so this will go to about 29.5309. And then if we want to just get it to the nearest foot, it's going to be about 30 feet further. Okay. So the outside tires will have to travel about 30 feet more than the inside tires when it makes a complete circle. Let's flip it over and look at our last page. All right, on our 4th page here, we have theorem 10-10, arc length. So now we want to know how long is the distance of the arc. So not the measure of the arc, the angle, but how long is it? So how far to walk from one part of the arc to the other. So the length of the arc of a circle is the product of the ratio of the measure of the arc divided by 360. So this tells us what percent of the circle we want. Circle's circumference. Okay, and then we're going to times it by the circumference of the circle. Okay, so we take the whole distance around the circle, what part, and then we times that by the percentage of the circle that we want. Okay, so complete the formula below. The length of arc AB, because that's what we're looking for when we go over here, is equal to the measure of AB divided by 360. Okay, so that gives me the part of the circle that I want, times by 2 pi r, which is the circumference of the circle. So it's going to be the measure of angle AB over 360 times by pi d. That's another formula we could use instead of 2 pi r, we could use pi d. So write T for true or F for false. The length of an arc is a fraction of the circumference of the circle. And this is going to be true. This is what we're looking for. We're looking for part of the circumference. And in circle O, the measure of AB is going to be equal to the measure of the central angle AOB. And this is also true. So if you have a circle with center O, the length of the measure of the arc AB from here to here is the same as the central angle's measure. Notice we're not looking for the distance from A to B. We just want to know the measure of the arc. Okay? So there's a difference between arc length and arc measure. So we have a lesson check here. Your class must find the length of AB. So we're looking for arc length now. A classmate submits the following solution. What is the error? So we're looking for the length of AB. So the measure of AB divided by 360 times 2 pi r. So the measure of AB, well, let's see. The measure of AC was 180. Okay, so AB is going to be 180 minus that 70, which will give us 110. So the length of, the measure of AB is 110. So this is good. 110 over 360. And then we're going to times it by 2 pi r. All right, so 2 pi r is our formula. But the problem that they did was they used the diameter for the radius. So this should actually be a 2 right here. All right, so is AC a semicircle? And this is yes. So does the measure of arc AB equal to 180 minus 70 equal to 110? So this is fine. To find the measure of AB, we do the semicircle minus BC, which will give us 110. So this is yes. This works out just fine. Is the length of the radius 4? This one's no. So what is the error? They use the diameter in place of the radius. Okay, so they could have used the formula pi d here, and that would have worked out fine. They could have stuck 4 in there, or they could have calculated the radius themselves. So if d was 4, then the radius would be 2, and put a 2 in that spot. Either one would work. All right, so we had some new vocabulary today that you should understand now. Circle is not new, that should be easy, but minor arc and major arc, I don't think you've ever heard before. And then circumference should be easy. Rate how well you can tell central angles, arcs, and circumferences. And you should be up in here somewhere, otherwise you want to go back and watch again. And remember, a minor arc needs 2 letters, because that shows you the short way around the circle, and the major arc needs 3 letters to show you the long way around the circle. Okay, and then a semicircle is exactly half of the circle arc. That's exactly half as big. All right, I'll see you in class next time.